right, everybody, welcome to R.6, rational exponents. Rational exponents is, properties of exponents, where the exponents is any form of a rational number. We've seen a little bit of this back in R3, when we did a little bit of the properties of exponents stuff. But now we're going to have all kinds of exponents that are fractions and stuff. By the way, I'm a huge Arizona Cardinals fan. I expect a good season this year. Picked up one of the best receivers in the league, Kyler Murray, coming back from Rookie of the Year. Serious playoff aspirations. No cap. All right, now we're going to revisit some of these properties of exponents. I put all them in boxes. I recommend you add this to your notes so you have all the exponent rules in one handy dandy spot. Let's go over them real quickly. The first one says if you have a to the negative n, you fix a negative exponent by putting it on the other side of the fraction. If it's on the bottom and it's negative, you would bring it up to the top. This one here, basically a to the power of 0 equals 1 to anything to the power of 0 equals 1, remember that? And then when you have a to the m divided by a to the n, well, that's the quotient property. If you remember the quotient rule for exponents, you would subtract the exponents. And if you have a to the m times a to the n, it's equal to a to the m plus n. So in other words, this is the product property of exponents. When you're multiplying, you would add the exponents. And this is the power rule. A to the m to the power of n is a to the m times n. So if you have a power to a power, you multiply the exponents. So we're gonna look at some more difficult ones. I mean, this is just like taking it a step up, and we're gonna see later on how these rational exponents convert to roots, but it's pretty cool. So let's see here. This looks messy. Let's see what we can do here. I have 27 to the 1/3 power times 27 to the 5/3 power. So if you're multiplying and you have the same base, you can add the exponent. And 1/3 plus 5/3 equals 6/3, and 6/3 is 2. So let's see. I have 27. All this top here simplifies to 27 to the second power. And then on the bottom, I have 27 to the 3rd power. Now, I have 27 squared on top, 27 cubed on the bottom. Are we having more 27s being multiplied on the top or on the bottom? Well, let's write it out just to give you an idea. I have on the top, I would have 27 times 27. I want to be able to get to do this mentally. I feel like if it was variables, we would be able to, but I want you to see with the numbers. On the bottom, we have 27 times 27 times 27. So I can cancel and cancel, and then I have 1 over 27 is my answer for this first one. Pretty neat. It looks messy, it looks scary, but if you follow your rules step by step and you don't break any rules, you can get through this. This is something it takes practice to get good at. You have to practice your homework. You get real familiar with the properties. I practice 10 of these every morning right when I get up. And I have been since I was your age. All right, I'm gonna erase this one here. Let's move on to the next one. All right. This one here is a real dipsy doodad. I should have probably saved this one for last. I don't want you to get mad at me. Okay. So where do you want to start? Let's see here. I know what I could do. Check this out. I should have saved this one for last and I didn't. I'm sorry. If I was to factor 81 and call it 9 times 9, is 9 times 9 the same thing as 81? It certainly is. 9 times 9 is 81. And does 9 factor to 3 times 3? It does, it certainly does. So if I wanted to say 3 times 3 times 3 times 3 instead of 81, I could do that, right? So I'm gonna call this 3 to the 4th power to the power of 5/4. So 3 to the 4th power to the power of 5/4 is the same as 81 to the 5/4. The only difference being is instead of writing 81 normally, I'm writing 81 like that, 3 to the 4th, that's 81. Let's do something similar here. I'm gonna call 4 2 times 2. So instead of calling 4, I'm going to call it 2 squared. So I have 2 squared to the negative 3/2 power. All right, I'm going to take that and put it over here so I have room to work. So I have 3 to the 4th to the 5/4, and then I have 2 to the 2nd to the negative 3/2. So what's the only difference between this here and this here? Well, I wrote 81 like that, and I wrote 4 like that. Okay, now when we have a power to a power, watch how neat this works out. It's so cool. Don't be mad at me. I know it's a hard one. But what is 4 times 5/4? 4 times 5 is 20. 20 divided by 4 is just 5. Or these 4s will cancel. We have 3 to the 5th. Now look better? That looks better. We don't have a fractional exponent anymore. And then 2 to the 2nd to the negative 3/2. Well, 2 times negative 3 is negative 6. And negative 6 over 2 is negative 3. Or this is just going to cancel that. So I get times 2 to the negative 3rd. Okay? Now keep in mind, I have a lot of people that are going to want to try to add these two exponents. Why can't we? Right, because they're different bases. But I will move this 2 down to the bottom. So what I get is 3 to the 5th over 2 to the 3rd. And 3 to the 5th, well, that's 3 times 3, well, 3 to the 4th would be 81. And 81 times 3 would be 243 over 8. What do you think about that one? That one was the real deal, right? All right, this one's not so bad. This one's a little easier. So, when we multiply, we're going to multiply the coefficients, right? So 6 times 2, 6 and 2 are the coefficients here. 6 times 2 is 12, but we've got y to the 2/3 and y to the 1/2. So what do I do when I have bases that are the same and exponents being multiplied? I have to add those exponents, right? So this is going to be y, and then I'm going to add 2/3 to 1/2 off to the side, but I'm going to put it over 6. I'm going to put it in the form of 6. So 2/3 would be the same as 4/6 plus 1/2 is the same as 3/6, and 4/6 plus 3/6 is 7/6. So really I've got y to the 7/6 here. And that, oh, I wrote it too. I'm glad I caught that. Y to the 7/6. So I have 12 times y to the 7/6. Moving forward in the next part of this lesson, we're going to learn how to simplify that rational exponent. It's going to be sweet. All right, now let's just try a couple more. Let's do this one. 3m to the 5/6 over y to the 3/4 squared times 8y cubed over m to the 6th to the 2/3. It looks messy, doesn't it? It looks scary. I promise this one's not as bad as it looks. All right, let's say I have 3 to the 2nd power, that's 9. This is a coefficient. Treat coefficients like coefficients. So 3 to the 2nd power is 9. Treat exponents like exponents. So 3 to the 2nd power is 9. I get 9 right there. Exponent to a power you multiply. So m to the 5/6 to the 2, I'm going to do 5/6 times 2, which is 10/6. And 10/6 simplifies to 5/3. If I'm moving too fast, tell me to stop. All right, so I got 3 to the 2nd is 9, and then I have m to the 5/3. Now, y to the 3rd to the 2nd is y to the 6/4. It's looking pretty gross, right? But don't worry, it kind of cleans itself up at the end. I'm excited for it. All right. So y to the 6/4, we can simplify 6/4 and write it as 3/2. Okay. Now, I don't really like 8 the way, because 8 to the 2/3, it's kind of messy. I got an idea. Let's write 8 instead of 8, 2 to to the third power. Why can't I do that? Is 8 the same as 2 to the third? What's 2 times 2 times 2? Well, that helps. Watch how it clears out that fraction. So now I have this to an exponent to another power. I can multiply. 3 times 2 is 6, and 6 over 3 is 2. So really, this turns into 2 squared, 2 to the second power, 2 squared, which is 4. That was pretty neat, right? And then, let's see, y to the third to the 2/3 power is just going to be y squared, okay? All right. And then, on the bottom, m to the 6 to the 2/3, 6 times 2 is 12, and 12 over 3 is 4. So I have m to the 4th power. Okay? I feel like you're going to be mad at me, but that's okay. Now, let's multiply across for the coefficients. 9 times 4 is 36. That takes care of our coefficients. And then let's handle our m business. I have m to the 5/3 on top and m to the 4th on bottom. Do I have more m's on top or on the bottom, and by how many? Well, it's hard to see in its current format, so I'm going to rewrite m to the 4th in the form of thirds. M to the 4th would be 12/3. That's the same thing as m to the 4th. Now, how much more m's are being multiplied? It's fractions, but we can still tell what number is more, what number is bigger, 12/3 or 5/3? 12/3 is bigger. How much is it bigger than? Let's see, 12/3 minus 5/3 is 7/3. So all of these are going to cancel, and 5/3 of the 12/3 here are going to cancel, leaving me on the bottom with m to the 7/3. Here, similarly with the y's, I have y to the 2nd on top and y to the 3/2 on the bottom. So I'm going to rewrite this exponent as a common denominator of this one. So instead of y squared, it'll be y to the 4/2. That's the same as y squared, right? Now, do I have more y's on top or on bottom, and by how many? How many more is 4/2 than 3/2? I'd be left, all of these are going to cancel because that's a smaller amount of y's, and here I have y to the 1/2 power. Maybe that was a little tough. But I hope you liked it. What do you think? We'll get to practice, guys. You practice them, you get better. Can I do just one more? All right. Let's do m to the 2/3 times m to the 7/3 plus 2m to the 1/3. Okay. Let's do it. We're distributing, right? What do you think? Does this look scary or no? This one's not bad. I think I said that about the last one, but I was lying before, and this time I'm telling the truth. So m to the 2/3 times m to the 7/3, when you multiply, what do you do with the exponents? You add them. So we get m to the 9/3. And m to the 2/3 times 2m to the 1/3 is 2m to the 3/3. Let's simplify, and I get m to the 3rd plus 2m to the 1st, or just 2m. And there we have it. What do you think? So we've got all these rules to practice with. We've done them before, but not at this high of a level. So it takes practice. In the homework, we're going to start with some easier ones. We're going to build us up to more difficult. We're going to get there. I'm proud of you guys. You can do it. All right, that's it for this part.